let's get on to what this talk's about, which is the Guideline Support Library 1 year later. So, what are we going to talk about today? Let's find out if I can hit the button that makes PowerPoint go forwards. Oh, or not. Hang on. Hello? Play? Or not? Okay. Well, we'll just try again the old-fashioned way, shall we? Restart. Wow, it really doesn't want to show you the slides. Well, it's going to be a very short talk. It just consists of starting there. Let's try starting from there instead. Is it Shift F5? There we are. So hopefully we can move forward from here. Yes, good. Just not backwards. Okay. So our agenda was, briefly, I'm going to talk about a refresher of what the GSL is, what our implementation is about. I'm going to talk about the things that have happened to the GSL in the past year, what we did, basically a sort of a summer vacation report, if you like. And then I'm going to talk about what we plan to do in the future, how you can help, how you can use it, and why it would be great if more people joined in and used it. So let's review what happened at this conference last year. Okay, so we announced the GSL. It was part of the announcement of the core guidelines. So the whole aim of the project, of the core guidelines plus the GSL, is to have more safety by construction in our programming. Simpler, better, more efficient, more fun programming, basically. And the Guideline Support Library, it's a collection of small foundational types to help you achieve that goal. They're referenced throughout the core guidelines in examples of how you could do something better than the bad old ways that exist in the language. So at the same time at CppCon last year, we publicly released the Microsoft implementation of that library. So it's open source, it's standards-based, it's portable, it's up there on GitHub for everybody to download and have a play with. It's under the MIT license. Out the box, we support MSVC, Clang, GCC. We've seen it ported to a bunch of platforms. It runs on various versions of Windows. It runs on Linux and OS X, which somebody just told me is called macOS now. Sorry, I live in the past. So that's what we did last year. We announced it, and then PowerPoint decided to. You get one slide at a time today with me, so I'll just do it that way. I don't know how these computer things work. They're super complicated, right? But somebody tells me like there's a better way to avoid bugs like this. I just don't know what it is. Yeah, nice. Yeah, that's a good idea. I'll have to tell my management that. They'll love it. So this is where we are 1 year later. Here's a snapshot of what it looks like on GitHub. So we've got 230 odd watches. I don't know what that is, but it's creepy because they look like the Eye of Sauron to me. I'm one of them apparently because I can unwatch at any time. We've got stars and we've got forks. I don't know what any of those things really mean or how they rate compared to other projects. I just thought I'd put them on there because they look like statistics. So enjoy them. Personally, if I was GitHub, I'd make them called like rainbows and ponies and unicorns or something, and that way I'd feel better about having 232 of them. As it is, I feel a little creeped out. We've had 353 commits. That's almost one per day, but obviously we got drunk sometimes and forgot. But in actual fact, if you look at the graphs on GitHub, it's a little bit more bursty than that, I'm afraid. And 41 contributors is a number I'm really excited by. The best news is only about six or seven of them work for my company. And out of that number, only about 2 or 3 directly report to me. So I actually think that's quite an achievement. We've got a broad range of people who've committed something at some point to the GSL, which is cool. I've given you some statistics there because everybody, well, actually, because I work in a management chain and I've just learned you always have to have a slide with some statistics. It doesn't really matter what they say, people just need to look at the numbers. So there's some statistics about issues and PRs. You can see that we've got a few outstanding at the moment. These numbers are a couple of days out of date. And I had to write this presentation, so probably the number got larger than it should. But we do resolve most of them. We occasionally reject things, and we get a few duplicates. But I think on the whole, we do a pretty good job of processing most of those issues. That tells me that people, when they join in on the effort, when you point out there's problems, and when we have these discussions on the repo, it actually results in things we accept and convert in one way or another into the GSL. So that tells me the whole sort of open source community process is working, which is good. And down the bottom there, you can see it's pretty small, right? It's 3,000 lines of code. I think I've seen plenty of functions inside my company that are 3,000 lines long, right? So it's a small amount of code with an equivalently small amount of tests, which is something I'd like to see change and grow and outstrip the size of the code over time, ideally. But the nice thing about it is it's small, it's compact. So a bit of a refresher about the GSL, right? The abstract concept as opposed to the implementation we were just talking about there. So as mentioned before, it's all about making your programming better. And there's two key focuses we've got in the library at an abstract level. The first is to encourage more memory safety, right? Don't overrun buffers anymore. Don't write to things you shouldn't. Don't dereference already deleted pointers or null pointers. These things are bad for programs and bad for our users. The second is type safety. If something's an integer, use it as an integer and not as a pointer, right? Because those sorts of practices lead to surprises and, again, nasty outcomes for everybody. So they're the two key concerns we have when we put together the functions and types in the library. The second part of it is it needs to be efficient. There's that whole close to the metal, zero overhead, promised land that C++ wants to lead us to. And the GSL is part of that whole story. So we have this really key focus in the library design, which is it should be no more overhead than if you wrote equivalent safe code by hand, right, using whatever techniques you like. That's not the same as low overhead as unsafe code, right? It'll always have a little bit of overhead compared to unsafe code, but the goal here is safety at a very affordable cost. So let's have a look at what's in it, because when I talked about the GSL last year, I didn't really get a great opportunity to dive into all the different parts, and some of them have been added in the past year. So I thought now was a good time to show off a list of words on a screen and bore you by walking you through them a little bit. So let's start on the left-hand side of the slide where the exciting stuff is. So the top of the list is obviously the owners and containers. So these are the way we manage allocations safely in programs, right? So hopefully unique pointer and shared pointer on that list are pretty familiar to everybody. And we're just talking about the standard library types there. It's not some nefarious alternate implementation in the GSL that has some strange behavior you didn't expect. It's the standard two of them. Owner of T is really like, the best way to think of it is unencapsulated unique pointer. It's a way of being able to mark legacy code that has raw pointers that point to heap allocations and say, you know what, here is the pointer that owns a heap allocation, in the same way that unique pointer does. It gives tools a better chance of working out what's going on and following around for leaks or for double deletes and so on. And it gives code reviewers and you and your friends a better chance of being able to follow what's going on as well. The last two on that list, DynArray is pretty simple. It's a runtime equivalent you might think of as, you might think of it as a runtime equivalent to stdarray. So it's a fixed size array, but the length of the array is determined at runtime rather than at compile time. So it's like vector, but it can't shrink or grow, is another way of putting it. And stack array, I like to think of as the extra credit challenge that Bjarne put in when he was contributing here. And that's the idea that it's the same thing as DynArray, but somehow its allocation is made from the stack rather than the heap for environments that want to see that efficiency. Turns out that's pretty hard to actually go and implement in a portable way. So I still like to see that as the extra credit challenge. If we can do that, we're winning. Underneath our owners and containers list, we have the views, so span, which I think most people have heard of by now, string span, the string equivalent. So these are ways of accessing sequences of objects without having to know how they're being stored elsewhere. So this is a nice way to separate concerns in your application. It allows us to be really careful about not overrunning bounds of things. There's a wealth of sort of improvements to the design of your code that you get from embracing things like string, span, and span. And the odd one out down the bottom there is Z-string with its const and its wide variance. Now, I think last year I had a pretty lame joke about how Z-string was the string because of Gabby Dos Reis and his strong French accent. This year, when I've written it as the CW out front, it looks more Polish to me, but I don't have a Polish team member to make the butt of my joke. So I'll just have to leave it up there and say it's like, I don't know, string? I'm not sure. But Z-string it is. In the utilities section, we have not null, which is a simple way to say the pointer here should never be null. Seems like a useful sort of a thing, especially for pointer parameters, which might be part of a legacy API. You don't want to replace them with a reference, but you do want to be able to say, hey, this thing, I don't ever want to get a null here, because we've all been in the case where we do and it's bad news. Finally, a simple way to produce a one-shot function that will execute when you leave scope, no matter how you leave the scope. So you can think of it as a quick and dirty RAII mechanism to use in your code. Hey, I'm writing something here. I know at the end of the scope I really need to clean up a resource. Wrap it in a lambda, pass it to a finally. Off you go. We have ensures and expects under contract support. They're like the nexus of evil in the GSL because they're macros, so therefore they're clearly evil. There are stand-ins for the lack of a contracts facility in the language today. Now, I'd love to see a contracts facility in the language one day, but until it comes, we have these macros that allow us to specify preconditions and postconditions for functions and have them enforced. And we'll dig a little bit more into that later in the talk about how the enforcement works. Under the conversions section, I'd start with narrowcast ahead of narrow. Narrowcast's a really simple concept. It's just static cast renamed. Right? And the idea of narrowcast is you use it where your static cast is narrowing something, right? You're going from an int to a short, right? It might be perfectly safe. Maybe your value is 2 in that variable. So it's fine. Go from an int to a short and your 2 will remain a 2. But maybe your value is, like 80,000 and it's going to change on its way from an int to a short on some platforms. So narrowcast lets you see, hey, I am explicitly moving this thing to a narrower representation space. And it just does exactly what static cast does. If you'd like some extra protection, sometimes we all would, narrow is your friend. Because narrow will actually go and assert, hey, I moved it to the short and it's still the same value as it was in the int. And if it's not, I'm going to do whatever the contract facility is configured to do in your library. Tell you things went wrong. So they're a great way to make more explicit in your code those narrowing conversions and, where you choose to, catch potential errors from them. Finally, there's the most speculative part of the library at the moment, is the concepts on the right-hand side of the screen, and we're really basically stealing them from the magnificent ranges by inclusion. The problem in my particular implementation is we don't have a great way to do concepts today, and we're waiting for the compiler support there. Once it comes, we can do something much better, but at least conceptually, they belong to GSL because we think they're a great thing when you're doing template metaprogramming in particular, or just template programming in general. So as I say, this is just a quick, rough guide. It's bigger than I did last year. There's probably things I've missed. There's URL down the bottom to the core guidelines themselves, which is the definitive reference on things that should be in the GSL. So that's the place to go and look. So whenever I talk about the GSL, people often say, yeah, but what about the standard library? Isn't that supposed to be the foundational set of types for programming in C++? It's the answer to all my needs. Why would I look at your stupid library? Right? It's a fair question. The standard library is awesome. I love it. It's getting better all the time. It's really cool talking about it at standards meetings. It's just, it's fascinating. But yeah, only 1 or 2 people, I think, got the very, very slight sarcasm in that statement. And the answer is the 2 are complementary and one's sort of feeding the other to a degree, right? So we already include some parts of the standard library in the GSL, and we're trying to standardize parts of the GSL that we think make sense to standardize. So the overlap between the 2, the intersection, should grow over time. So one way you can think about the GSL is like an extended version of or a TS, if you like, for some foundational types that we think belong in the standard library longer term. Not saying everything in the GSL will end up in the standard library, but we would hope that at least some significant types and functions within it will. And indeed, we've already started that process for span and byte, and they're both on track to go into the C++20 version of the standard library. So there is some truth to the rumor that we're trying to do this. Got a question there, Mr. Winters?
So why does the GSL re-export unique footage?
Right, it's a good question. Why does the GSL re-export unique pointer and shared pointer in its own namespace? The answer is we can imagine there are some environments where people will want a GSL implementation where their standard library may not have caught up to the point where it has a unique pointer and a shared pointer yet. And we want to give people some degree of consistency as well, right? That you're operating in the GSL and these are the types that belong in the GSL, even if they happen to come from your standard library.
Okay, so it's arguably a pre-adopt for someone that's not reached C++11.
So is it a pre-adopt for somebody who's not reached C++11? Yes, that's a good way of thinking of it. So, where can I get GSLs to actually play with? Well, I already mentioned we've got ours up on GitHub, and there's the URL at the top of the screen. I like to put all these things in the slide deck, so you can go have a look afterwards if you're interested, or if you haven't already. Our implementation's header only, so it's really easy. Just drop it into your favorite location, off you go. And yesterday, indeed, I packaged it up as a VC package, our exciting new, yep, there's another ad coming now, our exciting new package management system for deploying C++ libraries on Windows platforms. It is actually quite a cool thing. It's also open source. It's also, a community effort and designed to actually make things much easier and better. It only took me 20 minutes to put it together under Robert Schumacher's, I was going to say violent guidance, but he didn't hit me at all, right? His gaze is enough to make me do it. We also have it packaged up as a NuGet package, or you can just go pull the source from GitHub. Unlike Highlander, there's not just one. There cannot be only one. There's multiple GSLs. So there's ours, but Martin Mörner, Mattia Basaglia have both contributed implementations of the GSL that fit in a single header file, support C++ 98 compilers much better than our implementation does, which is basically not at all. And just have some slight variations in the way they do things. And just recently, Vicente has forked our GSL, and he's got an aim as well of providing better down-level compiler support with variations on our implementation. So all of these are fantastic things. I love having multiple implementations of the library out there. I think it's only a good thing for everybody, especially people on older platforms. It's great. Our implementation chooses to focus on C++11 as a minimum, as defined by C++11 plus some hacks for MSVC 2013 today. We want to move forward, and we want you to move forward onto newer compilers because the language only gets better with newer compilers, your code only gets better, all those things. So our implementation is going to try and push you forward over time, but we recognize that people have a need to move at their own pace, and it's great that there's other implementations to help you in that goal. If you know of any other implementations that I haven't listed here, please contact me and I'll get them added to this slide deck before it goes up on the web, because I'm all about advertising my friends in GSL love. So where's the documentation for all these wonderful things other than in my head? It's a great question. So the CPP core guidelines is the primary source of these things. And ultimately what we hope to have there is standard style, fairly dry specifications of everything. Fairly dry and detailed so that anyone can go and implement a GSL and get the right behavior out of their implementation if they want to. So I think that's an important goal. So far, we've just got a couple of standardization proposals for byte and span up there. It's definitely something we want to work on and improve and get more of the specifications up there in the very near future. But not everybody likes reading standards proposals. I know I don't like reading standards proposals, and they're certainly not my definition of good documentation. I think a lot of people like me find it easier to copy and paste, look at examples, get some sort of quick idea of how you use this and how, which things are easier to adopt than others. Where's a good place to start? So we want some tutorial style guidance as well. That would be a fantastic place for anybody who feels they have a bit of a knack for documentation to contribute to the project. We're going to try and make a start in the next short period of time after CppCon, but anybody who wants to, pitch in and help, please do. So who uses our implementation of this amazing beast called the GSL? And the answer is we do, right? We implemented this thing so we can use it inside Microsoft. So we dog food, which I find a repulsive term, actually. I prefer living the dream because I'm just a glass half full kind of guy. I like to think I'm heading towards the brave new future. And at the moment, as of today, we use it in the following places. CppCon, which is our static analysis tooling, integrates into Visual Studio over VC++ and tries to enforce some of the core guidelines. So that's built heavily using the GSL. Visual C++ itself, the compiler, has started to use the GSL just recently as part of a dog fooding effort. Oops, living the dream effort. Office, in some core shared components, has started to adopt the GSL. And one of the people responsible for that is sitting in this room right now, feeling nervous. There's the Edge HTML browser, which you get as a fantastic new thing on Windows 10. Also uses GSL, uses it in some key parts, like from memory, it's like cascading style sheet parsing and all those sorts of core parts of it. And they're looking to expand their adoption as well. There's currently some pilot work underway to get Windows using the GSL in earnest as well. So the idea is that by this time next year, I think all of the the big name flagship Microsoft products that everybody knows will have the GSL sitting inside them somewhere. And I think that would be, that's a fine tribute to our commitment to live the dream. There's also some other names up on the slide though, and there's some exciting open source projects that I know about that are also using the GSL. And they both happen to be projects whose contributors or leaders are giving talks or have given talks at this week's conference. So there's the Bareflank hypervisor that Ryan Quinn works on. And I think a hypervisor is a good example of a pretty low-level piece of code, and it's using the GSL. And there's been some great contributions and feedback that have come out of that usage, and the same for the Boost AFIO v2. Right, with Neil Douglas working there. They use the GSL. In fact, I think his slide deck contains actual GSL span being used in the wild for you to see. There you go. If you are aware of other projects and you'd like us to publicize your use of the GSL, again, insert your name here. Let me know. I like to tell the world about who's using it and whether or not they like it and how they use it. Okay, so we've finished with the what is it and overview and statistics. What did we do with it in the past year? So the GSL itself, in terms of specification as a library, was all about standardization. So we took ArrayView, StringView, and Byte to the standardization process to see if we could get them included in the standard library. Let's walk through those each. So ArrayView, the first thing that happened is it got renamed to Span. And I think that was just starting to happen at CppCon last year. We'd already got the feedback that, hey, ArrayView as a name is super overloaded, and there was a lot of discussion about alternatives, and in the usual semi-random way, Span was chosen as a better name. We also got a ton of really useful feedback about the interface of Span, what it should look like. And one of the most confusing areas was the original ArrayView and Span were multi-dimensional. And there was another proposal going forth for standardization of a multi-dimensional view over data type at the same time. So we looked at the two, and they did things kind of the same and then kind of different in places as well. And we wondered whether we should spend a lot of time trying to reconciling them into one mega proposal. And I think the decision we made was the right one, which was Span serves a really specific, super common use case, which is a single dimension array of data, right? You've got a contiguous sequence and it's got one dimension. That's sort of 90% of uses in C++ in the wild. So what we want for that is a type that's carefully designed to support those use cases, makes them as easy as possible to write, can be optimized as much as you like to make them as effective and efficient as possible, because multi-dimensional usage is a different beast in lots and lots of ways. You sometimes want to slice and stride data and it suddenly becomes non-contiguous. You want to do things like change the representation of the data, the order in which rows and columns, and you need to be able to support non-uniform memory architectures. And there's all these extra things that start bubbling up very quickly once you look at the multi-dimensional cases. So we thought by separating them away from Span, we could concentrate on one solid vocabulary type for the most common programming cases. So for those of you who missed the multi-dimensional support or started using it in some way, that became multi-span. It's not the best name. It's not the most original name. I just made it up in a hurry. But I left it there so people can continue to use that and we can look at what we want to do with multi-span going forward. We also got some good feedback about, fixing up small things like iterators, the set of constructors on span, and there's some of that work will still go on for a bit. There's a link there to the standardization proposal for span at the bottom of the slide. StringView we took along as well, but StringView suffered a less noble fate than span, and we ended up withdrawing it at the Oulu meeting. We ended up withdrawing it not because it's a bad idea, but because it turns out there's already another good idea in this going into the standard library that's a very similar idea, and that's StringView, or basic StringView to be technical. And it's a very similar concept. It's a view over a string, and they're just done different ways, effectively. So string span has an interface that's extremely similar to span by design, and StringView has an interface that is much closer to that of string, again, by design. And each, you can argue for the merits of each, but I think nobody could argue that you didn't want to have StringView in the library. It's a great idea. It works well with string. So having two types with very similar names and very similar purposes just seemed like a good way to confuse the world and annoy them at the same time. So we bowed out, and so string span lives on in the GSL. I'm not sure what we'll do with it going forward in a world with StringView. Right? We need to sort of see, can it stake out its own place in the same way that we did with span versus multi-dimensional span, right? Is there a way we separate these two to make sense of them? Or are we going to fold them together and just pick up and use StringView? I'm not 100% sure. That's something for the next 12 months of the GSL. Even though we withdrew string span, I wouldn't want you to think that zstring span or zstring is not a thing, right? So that type is still really useful. It's just an alias for a character pointer, but it's a useful alias because it tells you this char pointer is actually supposed to be null terminated, as opposed to it's just a pointer to a single character, or it's just a pointer to some object representation I'm looking at that may or may not have nulls in it, and so on and so on. So that's a great way to make your programs more expressive that we think you should still continue to use. Byte. Byte just seems like a really obvious idea as soon as you look at it. And it was funny how many people in the committee meetings would say, it's such an obvious thing that we need a byte, but it's a really hard thing to get agreement on. So happily, I think we have got some agreement on taking byte in. And the nice thing about it is we've managed to implement byte using existing library and language facilities. So it's just implemented as a enum over an unsigned char as its representation underneath. So that's a really nice, elegant representation. We do have to change the core language wording a little bit to make it okay to alias memory and object representations using a byte star, but that's a smaller change given it's already over the existing type that's allowed to do that. So it's simple, it's elegant, it's going to be added to the language. We just missed the cutoff for C++17. It turns out that even without night times, you can run out of time in Finland at a meeting. So unfortunately, it'll go to C++20, but that's life. Good feedback that we got on the type was to add some basic bitwise operations and comparisons. They work the same way as they would for unsigned char today. So it's a really unsurprising and uneventful and boring little type, but it says a lot about your programs because now you can distinguish numbers from characters from memory. And that to me is like a fundamental that you need to be able to do to be able to write and read programs fairly safely. So because I love examples that are really toy and cutesy, I put together this toy cutesy example of how these cool things we did with the spec work together nicely. So if we imagine we're going to do a very quick toy-like processing of a packet that's coming in from, I don't know, a network or something. It's got a fixed size header. Let's imagine header size is declared somewhere to be some constant number. The first thing we can do with these types is you can use a fixed size span if you're going to process the header. All right, and you're going to return a bool saying, oh, either I like the header or I don't. Right? And the header's going to tell you some other information in some way. Maybe you're going to store it somewhere. Maybe you'd return it in something more useful than a bool, but it's a toy. It had to fit on the screen. The point here is the span's passed by value because it's a cheap to copy around reference type. Right? It's just referring to some data. It's not storing the data. The data's stored wherever it came in, some buffer somewhere that you're processing over. Const byte lets you say very clearly, I'm not going to modify this stuff and I'm just looking at memory. I'm treating it as bytes. Maybe it's ASN.1 encoded or something like that. right? It's not an object I know about yet in any meaningful way. And you've specified the size and its fixed size. So then we can have another function that just processes the body, the rest of the packet. Now that can take a span too, because it's going to presumably operate over the same buffer. It's just taking a pointer again into the buffer. Again, you're just looking at the bytes, so they're just const byte. This time it's a dynamic span, right? Because you don't know how long the body of this packet will be. So dynamic and fixed size spans each have their own sort of success in this example. And then we have a little top level thing that's going to function, that's going to tie them together. And what we're going to point out here is you can still use pointer length in a function just like the bad old days if you want to, or more importantly, if you have to, right? And so maybe this is an API that we just can't change, right? We need it to be pointer length for some reason. Maybe it's an ABI boundary, right? Or maybe we just don't want to have to go update too many callers yet because we're in the process of adopting the GSL. And that's another way you need to sometimes think about these processes is I slowly worm my way of goodness into your source code base. You know, start at the center of the onion and work your way out. So we're going to take a pointer and a length, but we're going to make it a const byte pointer to make things a little bit safer and clearer. So then, the other reason I wanted to take a pointer length here is to point out that you can initialize the span with a pointer length, and what you've got is a really nice, clear trust point in your application. I'm making a statement about this pointer and this integer I got from somewhere. I'm making a statement that I trust that the two go together, and I trust that length is right. That's a statement that tools then have a real chance because if they understand span, they understand what you're saying at that line. Tools can go and look then for evidence that a lie was told to you, so you can find a bug. That's a good thing. And so can code reviewers, right? Lines like this where you initialize a span from a pointer length should be a red flag to everybody doing a code review. Gee, I hope we get this right, because otherwise it's going to be rotten all the way down to the core. The line afterwards is really nice because it illustrates one of the things I think is really useful about span, which is it lets you get rid of worrying about null pointers plus lengths being passed to you. If a null pointer is really important to you as a signaling mechanism, you can still call .data on span and ask to look at the pointer to see if it was null or not. But, 9 times out of 10, you don't really care if it was a null pointer passed to you or a valid pointer and a 0 length, right? All you care about is, do I have data and do I have enough data to operate on? Particularly in this case where we're looking for a fixed size header. So span wraps all that up for you. It won't null pointer dereference there. It'll just tell you whether or not it's got enough data. I think that in itself reduces the amount of error-prone, error-handling code you need to write. After that, you want to pass this dynamic span you've constructed, S, down to your verify header. Automatically, it will check to make sure that there is enough data to meet that fixed size requirement when it constructs the parameter to pass down to verify header. So span makes sure you can't make a mistake. So there's 2 checks in this function to make sure that there's header size number of bytes. There's one in the if test and one in the call to verify header. Now, you'd hope that good optimizing compilers will see the 2 checks, turn them into 1, and make that second conversion nice and cheap, and we'll talk about that a little bit later on. But the point is, the guarantee is there, even if somebody under maintenance goes and removes your if test that would make it safe, or modifies it, or gets it wrong, uses less than instead of less than equal to, or something like that. Finally, once we know that there's enough room for the header in the packet, we can skip past it to process the body. And we just do that using subspan. Subspan's cheap, it's fast, and it's safe because it checks to make sure that there's enough room to move past. Obviously, in this case, we feel like we're pretty confident about that because we've already made the previous 2 checks that there was header size bytes available. So that's why I love span. It makes programming so much simpler and safer. So that was my spiel about what happened to the GSL as a library over the past year with synthetic example. What happened to our implementation of it in the past year? Well, most of the time was spent tracking and tracing along with the standardization changes and keeping the implementation up to date, fixing bugs. And we did a lot of that, not just for span, byte, and string span, but also for the other types I've listed there on the screen. There's more work to go on all of them, I'm sure, but we did improve all of them at least a little bit and had some good discussions with the community. What's next for the GSL itself? Okay, so we've got to finish what we started. So we want to finish the standardization process. We want to add more documentation, as I talked about earlier. And we want to start thinking about standardizing new types and finishing their interface and make sure it's as tight as possible. And not null is the first one that leaps to mind. Multi-span, I think we need to go back and revisit. Do we want a multi-dimensional type? What does it look like? How does it play with the multi-dimensional view type that's proposed in the link at the bottom of the screen? And in the implementation, I want to take a crack at those exciting container types that I mentioned earlier. If anybody is interested in taking a crack at that before we get to it, please send us a PR. I would love some community contributions there. Away from specific types and implementation details, I'd like to do a much better job of release management for the GSL from now on. And a number of people have asked about this, right, on the repository. So we're going to start making releases. They'll be a fairly arbitrary thing. They're not going to necessarily correspond to, oh, and now it's feature complete, or, you know, it's just not the way GSL works, right? And the evolution process works. What they will correspond to is, hey, we've shipped an update to Visual C, or we've shipped the new version of Visual Studio with a new compiler in it there. Here's the version of the GSL that corresponds to that we tested with that compiler. It makes it easy for our customers and our users to know, oh, here's a snapshot of GSL that corresponds to a release of our compiler at least. I'm not against doing other releases for other reasons, but for me, that's the most useful release cycle we could follow that I can see at the moment. And I'll label the releases, and I'll make sure that the NuGet packages and the VC packages reflect those labels so you can go pick from your favorite package management system if that's how you acquire the GSL. We'll also be deprecating MSVC 2013 at some point in the next year, because at some point in the next year, I'm hoping that we'll see the next version of Visual Studio. And when we do, I only ever want to have to support 2 versions of our compiler at a time. Okay, because otherwise it's just too painful for words. And that's going to be the current shipping version of Visual Studio, which today is VS 2015, but at some point in the future it'll be VS Next, and the previous one. The previous one's currently VS 2013. Once the previous version becomes VS 2015, 2013 drops off my care list. And that's where we talk about how useful it is to have forks and other GSL implementations that might want to give you longer period of support for the older compilers. And last but not least, we're going to do some performance tuning, specifically of span, in the next year. So just a quick reminder that the target was 0 overhead for equivalent checks to handwritten code. So you've got one big knob you can turn today in the GSL to manage performance, and that's how are those contracts, ensures and expects, evaluated. So you can have them evaluated and turn into an immediate call to terminate if the check fails. You can have them evaluated, throw an exception, or you can have them evaluated and do nothing and enjoy the world of undefined behavior, which is obviously filled with, you know, rainbows, unicorns, beer, you name it, it's got it. I would recommend you choose the first, and that's what we ship in the products where we use the GSL. And just as a data point, even though we're talking about performance, I have not had a single complaint yet from internal users using the GSL that performance of span and its runtime checks cost them anything. Usually, they're such big pieces of software doing other things like loading web pages and images from networking. It doesn't actually make much difference in the mix to them. That doesn't mean we don't want to make it as small and fast and efficient as possible. And that doesn't mean it might not have an impact somewhere. It's just not a particularly measurable one that makes it unusable today. So for people who say, I can't use it till it's not optimized, you'd be in the minority, I think. If you really felt that way, you could use the bottom option, but you'd have to be super confident. The middle option I see is mainly about testing, but there are environments where you need to be able to handle an exception rather than fail fast. And there's been some interesting talks this week on that very topic, I think. So the tuning we're looking at doing is around span, and we wanted it to be with our compiler because we love our compiler. Currently, the optimizer support that was built does ship in the compiler and has since update 2. It's only for x64 architectures because you've got to start somewhere, other ones will follow. But it requires source changes to span that aren't on GitHub yet. So after CppCon, my long list of things to do to the GSL repository is push up those source changes into span. When I do that, I'm going to make a VC blog post because my PM loves it when we make VC blog posts and he's very good at making them. So He'll make the blog post, I should say, at the link down there on the screen. And we'll dive into some interesting, really nutty details of how it works and what to look for. But what I can give you a sneak peek of is these are the sorts of cases we're going to target with this first round of tuning. Now, they're all very simple. I mean, they're very simple cases because they fit on a screen. But they're very simple cases like in terms of optimization. You look at them and they make sense. If it's a fixed length span and you're indexing inside a function, it's a parameter, you're indexing inside that fixed length, well, construction of the span will have already done the range check, right? So you don't need to range check again over that red code, the A sub 4. So there's a simple, obvious case where people are going to expect to see that range check elided. All the places in red on the screen are places where today a range check would occur, right? Just blindly, every single time. And they're places where we think it probably shouldn't. So in the second example, if you test the condition in the if, and this is like my toy example earlier, you should probably elide the check that would happen at the line inside the if, right? Because it's redundant. And inside loops, you get even more opportunities because there's opportunities to hoist. Even if you need the check still, you can hoist the check. And in the last example, sometimes you hoist it, you might rewrite it to make more sense. These are all opportunities we're actively targeting. Now, you do get those optimizations today sometimes with span, right? Depending on your compiler, your optimization level, what your code looks like. Some compilers, including ours, will pick it up and do these things for you. But they're heavily dependent on what the code around looks like, right? Like all optimizations, they can be negated. So what we're hoping to do with this is make them negated less often. So make those optimizations a little more reliable in the wild. I've got a question there at the back.
Is this Microsoft compiler tag on something with a GSL namespace and span, or is it a built-in that you're
So the question is, are we tagging on GSL span, or is it a built-in or something we're looking into? Is that a reasonable?
Yeah, I was wondering, in other words, does the other GSL implementations also have the same advantage, or is it something specific to your?
Right. So yeah, would other GSL implementations have the same advantage or the same opportunities? So the answer is we're going to most likely change the way we do the contract checks rather than recognize span especially. And we'll change them to use at least one intrinsic that's known to our compiler and has a specific meaning and can be keyed off to do some cleverness if we like. So there's nothing stopping other GSL implementations adopting that same strategy when they're compiling on the right version of our compiler. So yeah, should be open to others. It's a great question, thank you. Oh, there's another one down there.
Along those lines, actually, of computing GSL, do they all use the same namespace?
That's a very, I don't know the answer. So do the other GSL implementations use the same namespace? Yeah, I mean, they should because it's prescribed in the core guidelines that everything should be in GSL, but I haven't checked, to be honest. I'm pretty sure that Martin Murners does. Vicente is a fork of ours, so it would. I don't know about Matthias. Okay, one more question. Jens.
Is there a test suite for GSL that I can test other versions of GSL if they are looking as advertised?
Right, so the question is there a test suite for the GSL? Yes. So our Microsoft implementation today has a test suite that is sort of effectively also the validation test suite because we happen to be the same people implementing it are contributing to the design to a large degree, especially as we've been tracking the standardization. So I would like to move parts of that test suite that are really about validating that the interface works as it should to the core guidelines repository ultimately. So there's one spot where you can go get all of that. So yeah, the answer is yes, there is a test suite today, but we probably need to clean it up and put it somewhere where people can consume it more easily for alternate implementations and to validate them. So the questions were well timed because we've hit my last slide, which is enthusing all of you to join the GSL party, right? I want more than 41 contributors next year on my little GitHub homepage. The more people that contribute to this, the better. People find bugs all the time. They find limitations with their specific usage. And I exhort you to come and join that collection of people and port the GSL, our implementation, start your own implementation that's alternative if you want to, use our GSL, tell us where it doesn't work for you, shortcomings, bugs, feedback. It all, as that set of open issues suggested, gets listened to, gets incorporated, makes it better for everybody. There's a bunch of links down the bottom there, and I think I've got time. I'm not sure, what is our time here? Yeah, I've got time for some questions if people have them. One down the end there.
So you mentioned
still stuck with the hourglass pattern?
So the question is span going to mandate an ABI for it, or as part of its specification, or are we still stuck with, hey, it's a span, you don't know how it's implemented? The current proposal for the standard library simply says it might be implemented as a pointer and length internally, but it doesn't specify implementation details. Therefore, it doesn't specify the ABI of span. So I think that's probably the way it's going to be.
It feels like we're in this horrible world where you can't pass vectors across library boundaries, and it would be really nice if I could just pass a span across the library boundary and avoid having to convert that.
Right. So I mean, it's a good point. You'd like to be able to pass span across ABI boundaries, even if you can't pass a vector. I think it's a reasonable thing. I sort of separate that issue from getting span standardized and right is a separate issue from should we have a standard ABI and what does it look like and so on and so forth. But it's a reasonable point. I have a lot of sympathy for that. Beeman.
What's the experience been with the people that are using it in production code?
Right, so what's the experience been with people using it on production code? So it's a fair question, and I think probably the overwhelming feedback we get initially is your documentation's a little light on. So just to hark on that point again, please help us out if you can with documentation, because you'll only make a lot of friends that way.
Are they finding problems in their code that they didn't know?
Yeah, right. Are they finding problems in their code they didn't know about? So it's interesting internally because we do run a whole suite of analysis tools and so on that we don't ship externally at this point that validate or check for a lot of the problems that these types are trying to overcome. So to a degree, we've already caught a lot of the low-hanging fruit, so it's unlikely span's going to stumble across a lot of that. We do get good feedback when we run certainly the core guidelines checking that there's lots of places where we find, hey, people are casting away const here, why? And then you ask this question, you drill through what is just a horrible piece of code and you realize this is really horrible, right? And a bug farm and somebody needs to clean it up. So the core guidelines checking we've done certainly finds things that smell bad, even if they're not an active bug today. What we've found and the feedback we've gotten is that even if we didn't find a smoking gun bug as you adopt span, and you sort of hope that you don't when it's shipping software, what you do find is, things got much, much cleaner. So that was certainly the case with Edge, right, where you'd have these complicated loops with all these pointers being swizzled around and incremented and decremented and so on to try and parse through stuff. And replacing it with span made it infinitely more readable about what was going on. I'm slicing up a chunk here. Now I'm chunking it in. Now I'm doing it again. And you knew it was being checked, so it would just go bang if something went wrong because it goes just to terminate. So people liked the fact that the code was getting certainly simpler, a bit clearer, and they felt there were more checks there in case there was a bug in there. Yes?
Static analyzer in your shipping Visual Studio, how much of that uses the GSL?
Right, so the static analysis in shipping Visual Studio, how much of it uses the GSL? So there's sort of two parts to the static analysis we ship with Visual Studio today. So one is just the basic set of checks that come with /analyze. That doesn't use the GSL because it's a separate code base from where we've done CPP core check, for instance, which is the new set of checks around the core guidelines. So we've only used the GSL in the CPP core check tool at this point, which hilariously is actually a much bigger code base than /analyze. It's built on a larger framework from an internal project. We are in the process of getting the /analyze onto GSL so that, again, in the next year, parts of the compiler, parts of /analyze will all use GSL too. Sorry, I'm just checking to see if I'm not favoring one side of the room. Yes, gentleman in the back.
On one of your previous slides on the to-do list, we discussed Null with shared footer and e-footer. Could you elaborate on what you're concerned about?
Sure. So the question is, in one of the previous slides, I mentioned concerns about not null with unique pointer and shared pointer, and could I elaborate? So there's an issue actually at the GitHub repository currently that just points out that there's some trickiness once you put a unique pointer or a shared pointer inside a not null at the moment. And the trickiness comes from, how do I call get? Is it the same, like, does get, what are the semantics of get? Does it even exist? on a not null unique pointer, for instance. So there's just some basic questions of, are we forwarding things properly in those cases? Because when we designed not null originally, we thought of it as a wrapper over a raw pointer, right? But the other problem is, how do we do moves properly, and what do they really mean? What happens if you call, reset? It's not like these are insoluble problems. We just want to make sure we've thought through them sufficiently for them to make sense. We feel like not null over a raw pointer is much simpler as a use case. You can design the interface and you can understand it pretty clearly. Once you're wrapping other people's smart pointers, or even wrapping span, right, you start to run into, what does that really mean? And do I forward .data on span, or do I call .get? And does that mean if I had code using a span and I made it a not null span, I'd have to change my .data to .get inside my function? We want to avoid those sorts of tricky cases cropping up in the future. We'd rather think about them now, I think. Yeah, I mean, I would. For now, I would say use not null on raw pointers, because that was certainly the thought process that led to its design, right? It's a good way to signal, hey, I'm passing by reference, but I'm not using a reference, I'm using a pointer, but I do expect there to always be an object at the end of the pointer. We didn't really envision, and I'd definitely use it for every smart pointer in the universe as well. I'm not saying it can't do that or some subset of that, I just don't think it was its original design inspiration.
Since the static analysis tool you demoed last year is not part of the GSL per se, how does it keep up with all the changes you do, and is it published?
Right, so the question is the static analysis tool we demoed last year, how does it keep up with the changes to the GSL, and how's it available, and basically what's the relationship, if you like, between the two. So the static analysis tool we demoed last year is best represented today in shipping bits by CppCon. So CppCon uses the GSL. It's rarely more than 2 weeks behind the GitHub version of the GSL in terms of the code it's actually using to be that we build it with. Currently, it doesn't recognize any of the GSL types, especially because the only core guidelines it enforces at the moment are just about pre-existing language features like don't use reinterpret cast, don't const cast away const. Please don't use a pointer, use a span instead. So to enforce a lot of those, you don't actually need to recognize GSL types and functions themselves. You're just looking at existing code patterns. One reason we've done that is we knew that span was changing. It was changing its name and its interface, and we wanted to give it a little bit of time to sort of come to rest. Over time, it will recognize those parts. Over time, we want to open source the code and the framework used for a lot of those checks, and then it's much easier to keep it all. You can, at that point, it's very easy to see the sync because one GitHub repo will simply reference the other, which is what we do internally right now.
Okay, so all the things you live demoed last year are still not available to the public?
Right, so the things we live demoed last year are still not available. So some of them are actually available in our experimental CppCon NuGet package. So if you download that, turn it on for your project, it will give you some degree of lifetime checking, which is the stuff I demoed on stage with Herb last year. It's not necessarily exactly the same set of checks we had on stage. There is a difference between the two. We played around with the implementation in between, to be honest. And it will change again, right? This is experimental work, and we're trying to work out what's the best subset of attacking the problem to put into a released tool so that it doesn't just give random warnings and a lot of false positives and annoy people too much. And I think the existing one falls into that category. So the basic story there is we've got something out there. It's certainly not finished cooking. It's got some more time to go. You should expect to see more releases in the next 12 months, and it should get better is the answer. Question?
You mentioned that you're only going to support Visual Studio 2015 and 13 and then go move. Have you come up with a similar scheme for the other compilers that your implementation supports?
Right, so it's a great question about compiler support. We talked about how we'll move just to have two concurrent releases being supported for MSVC, but what about other compilers that we currently know that we compile against and support? So the answer there will be driven, I think, somewhat by our internal usage of other compilers as much as anything, as well as external usage. I haven't heard anybody who uses those compilers internally or externally coming to me and saying, I've got two concurrent versions I need to support. for whatever reason, we happen to just sort of fix on a version and use it for a much longer time than the MSVC cycle. And, you know, one could say somewhat snarkily, maybe that's because MSVC is doing a lot of conformance catch-up work in the last 12 months, right? Fine, you know, I'll take that pot shot at myself and my own company. So I don't have a plan for it yet. I think we'll probably just continue to support the versions we have now as minimum versions for as long as that seems to work. Once we discover those minimum versions are missing something and we think it's an important something to be in the library, then we would probably bump onwards. But, you know, again, it's feedback. I'd love to hear from the community if people have particular preferences or needs who are using it. Thanks.
I was wondering, you know your port of Clang, so the Microsoft CodeGen edition of Clang. I have committed my own code. I now almost exclusively use that to write the code. And then once it's compiling with that, I then switch over to debugging using Microsoft's compiler. And that is a very good spread of portability without having to get surprised when they come to switch to Linux. So I was wondering, your static analyzer and span work, do you have any plans of getting that into your Microsoft CodeGen edition?
Right. So the question is basically, do we plan to put the static analyzer work and the optimization work into the Clang C2, as we call it, effort, the Clang with Microsoft CodeGen feature in Visual Studio? You know, it's an interesting question. So the static analysis part not so much at the moment. So the static analysis part is tied to the front end part of the compiler, the part that you're replacing with Clang when you use the Clang front end. So at the moment, there's no easy story to keep that going there. I guess the answer would be use Clang Analyze or Clang Tidy. If you've got Clang compliant code, might be one option. Or compile it again with the Microsoft front end with /analyze on it, or /analyze and CPP core check enabled, and you'd get that static analysis support. It doesn't really matter what code gen process is going on in the background. So you've got a couple of different paths there. In terms of the optimizations, they should find their way into the Clang with Microsoft code gen product, but over what time period and whether they're there already, I don't know off the top of my head, and I'd have to go check, to be honest.
Are there any plans to have the CPP core check tools available via some mechanism other than NuGet?
Right, yes. So the question was, is there a plan to have CPP core check, those static analysis tools, available via something other than NuGet? Yes. We plan to ship them in box with Visual Studio in the next version. So they're just there by default, and then they just go through the whole usual update mechanism every time we do an update, right? So that makes them easier for us to service and improve them incrementally in a rapid way, and it's much easier for everybody to acquire them. Then all you have to do is just turn them on in your project settings and you're done. So yeah, the NuGet package solution was a sort of a temporary path to get us up and running in VS 2015.
Do you currently have or plan to make a Visual Studio extension for CPP core checks? Visual Studio 2015?
2015, right. So do we plan to make an extension for CPP core check for VS 2015? Probably not, and probably because the new version is coming, and then things will be in box, and we tend to be focused on, you know, what can we ship and what do we want the experience to be next time we do a release. Because you can download it, add it to your project as a NuGet package, and turn it on, we feel people have a path to use it who want to adopt it now. And we just want to make that path smoother and just part of the, I bought Visual Studio, I acquired Visual Studio from my management, I turned it on, turned on the checks. So we will support the NuGet package for some period of time, but once we do the new release, like VS Next, then we'll just freeze that NuGet package as it was for VS 2015. And part of the reason there is when we make changes to CPP core check, do testing and improvement to it, we often find things we want to change in the compiler at the same time. And it's much easier to do that on the leading edge product that's the latest release. It's just the way it works. Sorry.
Again, will it be supported in VS Code?
Will it be supported in VS Code? I've wondered that myself sometimes as I've used VS Code. There's no reason it can't be supported in VS Code. It's just a matter of hooking the machinery up. So yeah, I mean, there's nothing stopping it, but I don't have a plan to go do it out of my team in the near future.
You mentioned optimizing the bounce checks. Is it possible to simply turn them off in a release build?
It is. So the question is, we talked about optimizing the bounds checks. Can you just turn them off? You can. At the moment, the hammer to do that is that configuration macro for the GSL as a whole. You can, GSL, no enforcement of contracts, or whatever the enormous, ugly, all caps name is. That's a big hammer, though. It turns off all the contract checks for all the types and functions in one go. We considered having a more fine-grained solution that let you just turn them off for span, or just turn them off for narrow, or whatever. I think the problem is it encourages people to turn them off, from my perspective. And I'd rather take a really wholehearted run first at making them efficient and affordable, and so as you don't notice them. And if we do all of that, and people still say, I really need these ones to turn off, then we could have a more fine-grained solution. But for now, you can, in release builds, just say, yep, don't check any of the contracts. I ran my test suite, I ran it in a debug mode, and I feel it's good enough, so, I'm prepared to take the risk. I think that's it. Well, thank you very much, everyone.